kind of the when I write this one, what I mean by this is you do first derivative, this one first, and then you apply the second derivative with respect to the other one. So you are doing the second derivative, but you're changing the sequence from one over there.
You said dy, dy.
Oh, dy, dy. Yeah, so this is dx. That's right. So dx, dy. So you apply, do this one differential first, and you do the second, but you are doing the dx first, and you do dy later, right? In this case, math told me that it doesn't matter which one you do first. Okay? So that is the underlying the math behind it, and then I'm going to use this concept to get to something that I really think is useful. So I'm going to write this one more time. It's a T ds minus P dv. All right. So this is a T, which is a first derivative with respect to entropy, right? So if I do U round S, then if I do round V, okay, second derivative, and this one to me is changing the temperature because this one itself is a temperature, okay? Divide by, what do you change?
Delta V.
Delta V, round V. Keeping what constant? So yeah, when you do that, the other one is constant. So that's the first one is essentially you're doing the differential twice. And that's this is the equation. What about the other one? I'm going to put the minus in front so that I don't have to worry about it. And then say pressure, which is now, pressure is internal energy differential with respect to volume. So you do the one more time, which is this whole thing, which is a minus P, another differential with respect to entropy change, right? So then do the entropy change. And keeping the other term constant is the same. So this is coming from the relationship about when you have a function that has a two dependent variable, whether you do first derivative with respect to entropy and the volume, or volume and the entropy, doesn't matter, so they have to be the same value. And this is one of the what is called the Maxwell relationship. And you guys can draw this relationship for the other, using the other functions, you can get this. So there are 4 Maxwell relationships. Which is, I'm going to summarize it later in this lecture. So once again, we are here, Maxwell relationship and exact differential, and the concept is here is energy of different form expressed in terms of volume, temperature, pressure, and an entropy. Okay? So this is how the functions are all related, and there are exact differential equation, and this equation is going to be used. And later we're going to continue to pounding on this equation again and again, and you will see me how this is going to be useful to understand the phase diagram, vapor pressure, equilibrium constant, temperature dependence, pressure dependence, and this is all has something to do with the